Hi class. So today we're going to continue with the whole idea of subnetting and what it is very important for you to understand binary. All right, and here it is that we have IP address which is 192.168.3.55, and we have the prefix in it /24. All right. So what do you mean by /24? /24 actually identify the class of the range of IP addresses, for example, and the net mask, which the net mask is 255.255.255.0. And if you were supposed to count out the 255.255.255.0 in dotted 32-bit binary notation, we're going to have a set of ones and zeros that is showing up. So, for example, 255 would give us 1, 2, 3, 4, 5, 6, 7, 8. If you was to check it up in place values, and another 255, 1, 2, 3, 4, 5, 6, 7, 8. Then another 255, 1, 2, 3, 4, 5, 6, 7, 8. And then the last one is a set of zeros, which is 1, 2, 3, 4, 5, 6, 7, 8. Now, if you also check up all these ones here, this first set ones here would basically, the first octet would be /8, right, which is class A. Then if you also check another set of ones, which should be /16, this is class B. And then if you also check the last set of ones, this is /24, as we get a /24 prefix here, this would be class C. Alright? And the reason why it is that we have to understand the whole concept of net mask is this is where the routers, you understand, is identify networks. And it goes through this through a process called ANDing. Alright? Okay? So if I was to first and foremost to take this number into dotted 32-bit binary notation 192, and I'm using place values here. The 192 will take the 128th place and the 68th place, and if I add up the two of them, I'll get 192. So I'll put 6 zeros. All right. If I was to get 168, I'm going to take the it's greater than 128, so I'll take out the first one. Then dotted decimal notation. These things come a little easier and second nature after a period in time. So I added 32. I will take off the 16, add the 8, right, and that will be 168 right there. And then I'll just put 1, 2, 3 because I wouldn't be putting on anything else. 3 is going to be simple, so I'm going to take 128 off, 64, 32, 16, 8, 4, and I'll just put only 1 on the 2. Alright, and 55 now, which is less than 128 and 64, so I'll take out the first 2. Then I'll put on the 32, the 16, I will take off the 8, and I'll just put on the other 3. Alright, so here it is that I have this IP address in 32-bit notation, right, binary notation. And again, this is how routers identify networks, all right, in terms of finding the network ID or the network address for this particular router. And they actually use the whole process of ANDing. So let me just talk about ANDing a little bit in terms of Boolean logic or logical conjunction. And according to the concept of A and a B, which is basically that when there's a true and a true is equal to a true, and when there's a true and a false equal to a false and a true equal to a false, and a false and a false equal to 0, right, or false. So basically you're replacing these like ones and zeros, all right. So basically where there's a 1 and a 0, all right, it would be a 0. If there's a 1 and a 1, it would be a 1. If there's a 0 and a 1, it would be 0. And if it's 0, 0, it's going to be 0. Alright? So, essentially, if you were supposed to add up all these numbers here using the concept of logical ANDing, we would get the network address for this particular host that is within this subnet name. So if you was to add the 1 and a 1, you're going to get a 1, right? Another 1 and a 1, I'm going to get another 1 here. All right. A 0 and a 1, and all these zeros and a 1 going to give us a set of false numbers. So we're going to just put 6 zeros here. And the same thing we're going to do here. 1 and a 1 is going to give us a 1. A 0 and a 1 is going to give us a 0. Alright, another 1, 0. A 1 and a 1 here will give us 1. And then the rest is 0. Alright, so I hope you're following me here. So we have this one here now. We're seeing 6 zeros and 2 ones here. So basically this will be simple. This will be 1, 2, 3, 4, 5, 6. And 2 ones, because at the end here, a 1 and a 1. And a 1 and a 1 here is equal to 1. And then this one here is 0 and a 0. Right? 1 and a 0. And all at the bottom is 0. So basically everything here is going to be 0. Right? So basically if you were to convert this back to dotted decimal notation, the network address for this particular number will be 192, right, dot 168 dot 3 dot 0, right? So essentially this is the way how routers would use logical ANDing to find the specific network for this host. So basically if you wanted to find the host, which is 55, it is on this network, which is 3.0. Alright? And we're going to go into a lot more because this is basically here classroom. The issue is when it becomes a little difficult, where we no longer have a /24 or probably a /8 or a /16, and they may ask you to borrow binary bits, and this is our whole idea of the magic numbers going to come in our another tutorial. So like for example, if I was to convert this /24 into a /28, now this becomes difficult because now this is classless, and this is where now we're going to use the concept of the magic number, all right, to solve and to find network addresses. And in the CCNA exam, they're going to be asking you, especially in this exam too as well, how to find a specific network. What is the network address of a specific host in a range of IP numbers?